Welcome to today's video. Our goal in today's video is to be able to graph equations, but now they're going to be written in standard form. We're going to show our mastery again by scoring at least an 80% on the exit ticket in class. Now, the big thing when we talk about graphing equation in standard form, we cannot just pull our slope and our y-intercept like we did when they're in slope-intercept form. So our first step needs to be to convert the equation into slope-intercept form. We've been doing this in class a couple times, and you guys kept asking why we needed to do it. Well, here's why. Because now when we go to graph it, it's going to make your life very simple. Once we turn it into slope-intercept form, we need to plot our y-intercept, which is 0b. Same thing as when you graphed it in slope-intercept form. Then use your slope and count, rise and then run. The big thing we want to focus on today is plotting more than 2 points if we can, just to make sure it is a straight line. If we look at our first example, we have 5x minus y equals 5. I wrote the slope-intercept form at the top just as a visual reminder. So I start with my equation, and my goal is to get y by itself. So I'm going to start with the 5x and subtract 5x on both sides. I now have negative y equals negative 5x plus 5. Although y is on the left-hand side without any other variables, we do have that negative sign in front of it that we want to get rid of. So we're going to divide all my terms by negative 1. I'm now left with y equals negative 5 divided by negative 1 is positive 5x. Positive 5 divided by negative 1 is negative 5. So now that I have my slope-intercept form, I have my value for m, and I have my value for b, or my slope and my y-intercept. So my slope-intercept form is 5x minus 5. That makes my starting point 0, negative 5. Negative 5 is my y-intercept. Now for my slope, it is always rise over run. Well, in this case, I only have one number. To give me that run, I need to turn positive 5 into a fraction. I'm just going to divide it by 1. If we were to simplify 5 divided by 1, we get 5. This is why I can add that 1. My rise becomes 5, which means I'm going in an upward direction. My run is 1, which means I'm moving in a right-hand direction. It is a positive slope, so when I look at it from left to right, it needs to be moving in the positive direction. Now, if we go to plot this, I'm going to plot 0, negative 5. I'm going to go up 5 and over 1 and plot my second point. I'm going to keep doing this until I can't plot any more points on the graph. So I have a third point. Now I'm off the graph, so I'm going to connect my 3 points with my straight line. This is now your line for your linear equation y equals 5x minus 5, and also your standard form of 5x minus y equals 5. If we look at our second example, we have 5x plus 3y equals negative 15. Again, I want to turn it into slope-intercept form, so I'm going to start by subtracting my x. In this case, we're going to subtract 5x on both sides. We're left with 3y equals negative 5x minus 15. The variables are all for y on one side, but now I need to get rid of the coefficient. 3 is being multiplied by y, so I'm going to divide by 3 on both sides. I'm left with y equals negative 5/3 x, and 15 divided by 3 gives me minus 5. I'm now in slope-intercept form, and I have my m, and I have my b. So when I go to look at it, my slope-intercept is negative 5/3 x minus 5. This makes my starting point 0, negative 5, since negative 5 is my y-intercept. Now, for the slope in this case, when you have a negative fraction, you need to put that negative sign with only one of the numerator or the denominator. You cannot pair it with both. If you put it with both, you're technically giving yourself a positive answer because a negative divided by a negative is a positive. So my rise in this case is going to be negative 5, which puts me moving downwards, and my run is going to be positive 3, which makes it move to the right. My direction is a negative slope, so when I look at it from left to right, it needs to be moving in a negative direction. I'm going to start by plotting my y-intercept, I'm going to go down 5. Well, when I go down 5, it takes me off the graph. What you can do, since it has to be with one of the numbers, if that takes you off the graph, I'm going to switch where my negative sign is. I'm going to make 5 positive, and I'm going to move up, but now instead of a positive 3, I'm going to move negative 3, which means I'm going to move 3 spots to the left. So if I go up 5, I can go over 3. And if you need to check yourself, if you're not sure that it seems correct, count down. If I go down 5 and over 3, I end up at my y-intercept. So even though it looks a little different, it still gives you the same answer. Again, I'm going to keep plotting points until I can't plot anymore. And in this case, I have my 3 points. I'm going to connect them with a straight line. That is now the graph of my linear equation. For example 3, we have 8x minus y equals 4. Again, let's turn it into slope-intercept form. We're going to subtract 8x on both sides. We're left with negative y equals negative 8x plus 4. The variable y is not by itself yet. We still have a negative sign, so I'm going to divide all my terms by negative 1. I'm left with y equals negative 8 divided by negative 1 is positive 8x. Positive 4 divided by negative 1 is negative 4. I'm now in slope-intercept form. I have my m and I have my b. So now we can look at graphing it. Slope-intercept form is y equals 8x minus 4. That makes my starting point 0, negative 4. Rise over run, again, we just have 8, so we're going to turn it into 8 over 1. That means I'm going rising 8 in the upward direction, and I'm moving 1 spot towards the right. It is a positive slope, so again, when I look left to right, it needs to be going in the positive direction. If I plot my y-intercept, now I'm going to count 8 up and over 1. Now, in this case, we can only plot those 2 points before we go off the graph, and that's fine. You can make a straight line with 2 points. We just want to get in the habit of plotting as many as possible. Again, we're going to draw our line, and that is your graph for your linear equation and your standard form equation. Our last example on these notes, we have 4x plus 3y equals negative 3. Again, we're going to turn it into slope-intercept form. We're going to start by subtracting 4x on both sides. I have 3y equals negative 4x minus 3. Y needs to be by itself. Right now it has a coefficient of 3, so I'm going to divide all my terms by positive 3. I then get y equals negative 4/3 x, and a negative 3 divided by 3 gives me a negative 1. Now I'm in slope-intercept form. I have my m and I have my b, so we can look at graphing it. Slope-intercept form again is negative 4/3 x minus 1. That makes my starting point 0, negative 1. It's my b value. Again, rise over run, we have a negative fraction, so put the negative sign with only one of the numbers. I'm going to put it with the 4, which means I'm going negative 4 in the downward direction, and I'm going to have a positive 3 going towards the right. My slope is negative, so when I look at it going from left to right, it needs to be going in the negative direction. I'm going to plot my y-intercept, and now I'm going to go down 4 and to the right 3. I have no more points, so I'm going to connect them with my straight line, and that is the graph of your linear equation and your standard form. At this point, these are all the examples. You can move on to the practice problems on the back of the notes, or if you need to go back through some of these examples, please feel free to do so. Look forward to seeing you in class tomorrow.